Welcome to Excellent Scholars Academy. And today we're going to look at the series and parallel combination of resistors. So we want to find the equivalent resistance through this circuit drawn here. All right, we want to find the total resistance or the equivalent resistance in this circuit drawn here, or of this circuit drawn here. Now, how do we do that? Now, the first thing you have to realize is that for us to find the total resistance or the equivalent resistance, we have to start from behind. You don't start from here, you start from here. All right? Now, this place is open, this place is closed, so you start from here. All right? You start from behind. So now, first thing you will notice is that R1 and R2, which is the 2 ohms and the 2 ohms resistor here, are in parallel because they are connected across each other. Is it that they are connected across like this, or across like this, or across like this? All right? So they are connected what? Across each other, opposite each other. All right? So meaning they are in parallel. So you notice that what? R1 is in parallel with what? R2. This is the symbol for writing. If you want to write two resistors in parallel, this is the symbol, all right, for parallelism, all right, or parallel. All right. So it means that what? R1, 2, which is the combination of resistor 1 and 2, is going to be equal to what? Now, when two resistors are connected in parallel, what do? We multiply them divided by the addition of both of them. So it becomes what? 2 times 2 over 2 plus 2. So it's going to give us 2 times 2 gives us what? 4. Divided by 2 plus 2 gives us the same 4. That's going to be what? 1 ohms. Now, if you notice something about these two resistors, they have the same value and they are connected in parallel. So note that also when two resistors are connected in parallel, all right, and they have the same value, the combination of the resistance or the total resistance between them is going to be half of their value. So this and this are in parallel and they have the value of 2 ohms, 2 ohms. So the combination of both of them is going to be 1 ohms. Take note of that. Now let's continue. Now this circuit is going to reduce to this. This circuit is going to, haven't found the combination of this and this. This circuit reduces to this. So you're going to have this. So now this and this were combined to give us 1 ohm. So this is 1 ohm. So this is R12. Now this is the 3 ohms that was here, which is R3. And then this is the what? 4 ohms that was here, which is R4. All right. Now, so if you notice, we've combined this and it gave us 1 ohms. And the circuit reduces to this. If you notice, this R3 and R12, that's the 3 ohms resistor and the 1 ohms resistor, are in series. All right. They are in what? Series. It's just like a wire. All right. Now, let me make example of this. Now, if I connect, let's say this hand and this hand and this hand are resistors. They are connected in series. Even though I bend the wire like this, they are still connected in series. All right. So this hand is a resistor, this hand is a resistor. They are still connected in series. So it's like this is like a wire that was bent, but they are still connected in what? In series. So meaning that what? R3 and R12, that's the 3 ohms and 1 ohms resistor are in series. So the combination of R12 and R3, that's R123, is going to be equal to what? 3 plus 1. When two resistors are connected in series, we add them. So 3 plus 1 is going to be equal to what? 4 ohms. All right? Now the circuit is going to reduce to this. Let me put this here. I forgot to put this here. So it's going to, the circuit now is going to reduce to this. What you've combined this and this, so this is what the circuit will reduce to. Now this will now join. This has been combined to now become in parallel with this. So see what the circuit reduces to. It reduces to this. So this is our 4 ohms resistor, which is R4. Now we combine this and this now to give us what? 4 ohms. All right, and this is what? R123. All right, R123. Now, so this and this combined to now come here and we will now be in parallel with this R4, which is the 4 ohms resistor. All right, so that's what happens next. So this circuit now has been reduced to this. From this, we reduce this to this and then this now. All right, now, so now if you notice, R4 and R123 are in parallel. That's the 4 ohms resistor and the 4 ohms resistor here are in parallel. So the equivalent resistance or the total resistance, which is the same thing as R1234, that's the combination of both of them, they are in parallel. So it becomes 4 times 4 over 4 plus 4. Now, the total resistance is actually what? 2, because both of them are connected in parallel and they have the same value. All right? But 4 times 4 is what? 16 over 4 plus 4 is what? 8. 16 divided by 8 gives us what? 2 ohms. All right? So you can confirm that when two resistors are connected in parallel, you do this. All right? You multiply them, then divided by adding them. Or also, if they have the same value and they're connected in parallel, the combination of both of them is going to be half of the value, which is going to be 2 ohms resistor. So the equivalent resistance of this circuit drawn here is what? 2 ohms. All right? So 2 ohms is our final answer. So that's how to find the equivalent resistance of a circuit drawn like this. All right? Now, make sure you like this video, share this video, and hit the subscribe button so that when I upload more videos like this, you get notified. And also hit the notification button so when I upload more videos like this, you get notified.